Hey guys, happy Tuesday. Welcome to our second week of asynchronous learning. Today we are going to continue our work with CP&M and move on to lesson 1.1.2. So go ahead, get your online ebook opened up along with your notebook so you can take notes and do some scratch work today. And we're going to get All right, guys, so we are going to take a look at lesson 1.1.3. Don't forget to put this in your notebook and under your table of contents. I'm going to do that now. Our title today is Domain and Range. Don't forget your page number on there. So I have today's lesson number and my title. And I'm going to bring that over to my table of contents. And I've got that in my table of contents as well. All right, now we are ready to get started. So our intro says, in lesson 1.1.2, you worked with your graphing calculator, or Desmos, to see complete graphs of functions and to determine what information was useful to describe those functions completely. In this lesson, you will look at more functions, this time thinking about what input and output values are possible. You will also learn about additional tools on your graphing calculator that allow you to see a complete graph. As you work with your team, remember to ask each other questions such as, what values are possible? Can we see the complete graph? What other information can we use to describe a function? So remember, yesterday we talked about complete graphs. To make a graph complete, we want to be able to see as much of the graph as possible, be able to identify X and Y intercepts, maximum or minimums, if that is applicable. Okay, so before we dive into this lesson, I want to do a quick review on domain and range. So I have a neat Desmos activity here that we're going to take a look at. By looking at domain using this graph here. So our challenge, points launched from the x-axis can hit the y-axis only by deflecting off a green point. Mission to expose all the landing sites. So if we are going to go off our x-axis, it'll hit green and then go over here. So this number is 1. So I'm going to enter an x value of 1. Let's try it out. And it works. Our next one, I'm going to try 2. And it works. This one here is a little bit trickier. Looks like we're between 2 and 3, so that puts me at what? 2.5. Okay, so far so good. Here I've got, it looks like about 3.5. Okay, this one here, it looks a little bit over 4.5, so I'm going to try 4.6 and let's see what happens. It didn't work, so I got an X here. However, one nice thing about Desmos is that you can click on the point and it tells you exactly what your X is. So let's try that again with 4.75. And there we go. Let's make a table, all the possible launch sites. So we used 1, we used 2, we had 2.5. We had 3.5 and 4.75. Okay, and when number 1 took off, it hit here and ended up over at 1. When 2 took off, it also landed over at 2. When our 2.5 took off, it landed on 3. And these last two both ended on 4. So this is what our graph looked like on the previous slide when we launched our points and they ended up on the Y. So our launch points, this is our domain. Our domain is always our x's. Our landing points were on the y, and that is my range. A more formal definition. In mathematics, the word domain is used to describe all points on the x-axis which can be input to a function to obtain a valid output. So our domain is our input, our range is our output. The word range is used to describe all the possible outputs for a function. That is, the range is the collection of all possible landing sites. So for this one, we want to predict the domain and range of this function. We're going to use the red tool to shade the domain on the x-axis and the blue tool to shade the range on the y-axis. So there are a few different options up here. We have a pencil to free draw. We have a line so that it can be straight, and we have an eraser. Also, you can drop down and change our colors here. But we're going to start with red. So red is supposed to be predicting our x-axis or our domain. So I'm going to use my line tool so it can be nice and straight here. So remember, domain is all of the possible x values. And when I'm looking for these, I'm looking for like the end or the outer points, as far as it can go. So this function, when it goes as far as it can to the left, on the x, we are at -2. And if I keep going over here, the farthest I can go on the x is at 1. So this is going to be my domain. Range is my up and down. So I'm going to change this to blue. And we are going to start at 0. This is my lowest point on the y. And we're going to go all the way up to my highest, which is at 8. Okay. So we want to look at our boundaries. So we're going to fill in the upper and lower boundaries of the inequalities for the domain and range in the input boxes for the table below. On this slide, we will complete our inequality notation. Inequality notation is super helpful when we're working with continuous functions. Remember, continuous functions have an infinite number of points. If we're working with discrete functions, those are just specific points on a graph, then we would use just a list to write out our domain and range. But in this case, we have a ton of points, so we are going to use inequality notation. So my lower boundary, and we're looking at the x's, my lowest x is over here at -2, and my highest x is here at 1. We'll do the same with our y's. What do you think the lowest y is? And down here at 0. And the biggest way up here at 8. Oops, 8. So this is what our inequality notation would look like. Let's check our answer here. Oh, that's pretty cool. So we can see that our domain matched up, and so did our range. Let's see that one more time. Now we're going to ponder something different. So let's predict the domain of this function, and then we're going to click reveal. So if I'm looking at domain, I'm looking at my farthest x point on the left, and then my farthest to the right. So for me, it looks like these are at -20 and 20. So I'm going to write an inequality using these. So we had -20, and then the signs that we used were here, and then greater than 20. So I'm going to submit this, and let's click to reveal our domain. Look, it just keeps going and going and going. So did our domain really stop at -20 and 20? Where did all those points come from? So what do you think would happen if we zoomed out further on this graph to see the complete graph? Yeah, I think it would go on and on and on forever. We don't see arrows here, but if we zoomed out, we would see this to continually go. The same thing will happen with our range here. So it stops here, but this is going on and on and on forever. So something that we use to describe these types of functions is our infinity sign, and you'll learn more about that today. Do a quick card sort here and try to figure out if we can match the domain and range. So we basically have, I'm going to move some of this stuff out of the way. We have 3 graphs here, and they all look very different. Okay, so I'm going to start with this middle one here, the circle, because it has some definitive points for me. So I know that my domain is going from -5 to 5. So here I have domain -5 to 5. Let's match that up. Same with my range. It stops. We have a point at -5 and one up here. So let's put this one with that as well. Okay, so now I have domains of going from infinity to, -infinity to infinity, or -5 to infinity. So if I look at this graph here, and the point -5 is right here. It looks like my graph is not even crossing that right now. So I think that one's going to go on and on forever in this direction, and on forever in this direction. So what does that tell me? Which of my two domain choices is it going to be? Yeah, it's going to be the one with both of our infinities. And so that leaves this domain over here, which makes sense because I have a point at -5, and then I'm going in the positive infinity direction. Now I have to look at my two ranges. So using that same idea, we can tell here that this function stops, the lowest it goes is -5, and then it goes up forever. So I know that my range has to have a -5 in it. Now if I look at this range, it's going down in the y's forever and up in the y's forever. So that tells me my infinity. So here are 3 different functions, all with different types of domain and range. Your domain and range could be 2 specific numbers as your endpoints, or you might have to use infinity to describe graphs that go on and on forever. That was a quick recap on domain and range. So now you are going to dive into your own Desmos activity for 1.1.3 to explore more on domain and range. Make sure to take notes as you go.